Hi folks, welcome to another Cancha tutorial, this time on data conditioning. You've got to get the data in the right shape in order to get it into Cancha. So basically there's three kinds of data you can import. Two of them are useful, one of them's not. First one is the numerical, any kind of number, integers or real numbers, no problem. Second one is categorical. There's two types, ordinal and nominal. Ordinal is where order is important. So high, medium and low is an example. Could be that your alteration intensity is 1, 2, 3, for example, so there's an order for those categories. And you'll notice if you say 1, 2 and 3, those are numbers, yes, but in that case it's more useful as a category because there's not going to be any data at 1.5 or 1.7. It's either 1, 2 or 3. So when you're doing analysis in Cancha, it's better to have that as a categorical. Nominal, on the other hand, apples, oranges and bananas, could be sandstone, limestone and marble or something like that. These things, there's no progression between them. You just need to give them names. Okay, so that's nominal categorical. The other one is text. You can import things as text. It'll be there in the table view, but you won't be able to use it anywhere in the analysis. So what we need the data to be well formatted. It has to be a single row at the top. The text can contain all kinds of symbols, spaces, stuff like that, no problem. But you can't have repeated field names. So the feature names at the top can't be repeated, and it can only be a single row. They have to be continuous rows and continuous columns. Can't have any gaps either in the rows or in the columns. And you'll notice that everything's nicely all numerical or all categorical and stuff like that. So that's what we want. And what we usually get is something more like this, where you've got less than symbols, you've got greater than symbols, you've got different words that people have put here and there. You've got, people made annotations on things. Here we've got two rows that are repeated. The 26 and 28 interval is actually repeated. So what's that all about? There's columns which are completely empty. There are columns with gaps, and gaps is fine. This is what we call null in data science, and that just basically means there's no data. Having no data is no problem at all. If you want to have a zero number, then you should put the number 0. If you want it to be empty because you haven't done a determination, leave it empty. Okay. You'll notice here that and for andesite is in lowercase here and uppercase here. They will be detected as two different labels in Cancha. We worked on a project where pyrite was named 6 different ways on the same project, 3 in English and 3 in Spanish. So we had 6 different labels for pyrite. That's not acceptable. It all has to be consistent. Okay, obviously, you can't have 2 tables. Like I said before, it has to be continuous. So that's what we get, and what we have to do is shave the yak. This is where the term shaving the yak comes from. We didn't make it up. It's a data science term. Yaks don't look too pretty, but if you give them a shave, they run like hell. So basically, it's all about conditioning the data in order to get it into shape for the analysis. So you need to go through the data. Personally, I prefer to do it in things like Excel if I can, just to clean it up. Cancha is not the best tool for data conditioning. There are some things that can help that I'll show you in a second. But if you've got things like greater than and less than symbols or percents and these sort of things, it is easy to clean those up in Excel, for example, before you get started. So you need to get rid of all those things that will make numbers text. You'll need to look for repeated column names, repeated row names and things like that. And look for problems that might be, with the spelling of certain labels, and just make sure that everything's labeled in a way that you can understand it when you're doing your analysis. Okay, so without further ado, I will go into Cancha. And basically what we have here is a bunch of data that I've imported, and I'm going to go ahead and draw a graph. Why don't we draw a graph of, silver? Oh, what happened? I get an error message, error 4000. There's 4000 errors in Cancha apparently. This feature needs some work before you can use it. Please edit the feature to correct the issue. So basically this is saying you need to shave the yak. Everything with this nuclear symbol is toxic. It's data that's got, Cancha's detected there's some problem with it, and if you try to work with it, it'll probably crash the software. So we come to features, and there's this radioactive symbol here in features, and you say this is shave the yak. What you do is a table, you pull the table name into this box here. And you can see when I pull the table name in, I get all these problems, and you can see a lot of them are greater than and less than symbols. And basically what you do is just go down 1, 1, 1, 1, 1, 1. So text, this is NA. This is obviously an artifact from an Excel calculation. So we don't want to give that a number. If it's not available, we'll just call it null, call it empty. Whereas less than 0.03, that's fine. We'll call that 0 in this case. So NSS, not sufficient sample, null. Didn't get an assay, just put nothing. Whereas 0.2, 0 is fine. Greater than 100, 100. So this is what we do anyway. You decide what you want to do. You can change the value here if you want. But basically, I'm going to go down here, and I'm just going to go ahead and choose null for the text ones, and the values for the less than and greater than symbols. You'll notice here this was less than 10, and because it's greater than 1, it offered 5, which is half of 10 as a recommended value. It shouldn't make any difference in geometallurgical analysis. Basically, what it's saying is if it's below detection, if it's going to be useful for geomet, it's just important to recognize that it's a low value. Whether you give it 0, or you could replace it with 0, you could replace it by half the detection limit, doesn't matter for purposes of geometallurgical analysis. If too many values are less than, then you'll find that you just won't have contrast, and it won't be numerically interesting for geometallurgical models to use a field that has a lot of stuff that's below detection. It's just not a valid thing for mathematical analysis. So I've gone down, selected all these values and the nulls, and then I just hit apply. And so now I'll go back to do a graph, and now I'll go ahead. You'll notice the radioactive symbols aren't there anymore. I'll do a graph of gold versus aluminium, which is a really useless graph. But there you go, got full use of the data. Oh, still got a radioactive one there. Let's just, for the sake of it, go back, and I don't want anybody to accuse me of whitewashing. Put that on there. It says that I've got greater than 5,000. Okay, so I don't know why I missed that. But we're done. And now if we go back to analysis, I can get that manganese, I think it was, and I can draw a graph with it. Works fine. Okay, so that's data conditioning. Thanks.